Hello everybody. My goal in this short session is to publish the new changes to the finite state machine library. I have some code to cover with the tests. I think the most important tests will be here, covering update method and trigger state. But most importantly, in this session, I will check all the questions and responses that people received on Stack Overflow on the topic of ECS and state. And we're gonna go through that in a second. But first, I want to finish this the code coverage here, and then we'll move to that. Okay, so let's see, what do we have missing? Unregistered state with name. This is pretty straightforward. And I also changed my keyboard and mouse to I no longer have mechanical keyboard. I have a wireless Logitech mouse and keyboard because my wrist was taking pretty much damage from the former. Okay, let's see. Unregistered state means, gotta remember that I have a different key bindings. Means that I'm going to register a state, and then I'm gonna unregister it. And then expect SM get state title to be undefined. Actually, no, what was the we should have exceptions here to throw error. Get default state error as well, and current state. Maybe I should do also a recap on the Miro board and see and actually put the state there. Okay, now we have queue state. It's more like a private method. I'm not sure if this is worth checking. Okay, let's take care of trigger state. Trigger state. Non-existent state returns false. This new keyboard is called the wave keys, and it's kind of a wave form, so I think it will better protect my wrists. So far so good, so I don't know. I'll see. ASM trigger state APC. So expect yeah, still hitting the wrong keyboard. What's next here? This current state, if okay. If no current state is exist, then set a new state and enter it. Okay, so we have state manager. If not current state, then enter it. So I need to spy on enter. Trigger state idle. So I'm going to expect the trigger state to return to be true, and get current state to be instance of idle state. And what else? And that the enter is hold. Yeah, and that works. Then we have something that we never tested here. Else path not taken. So trigger state. If not current state. Current state is finished. It a attempting to trigger a state with lower than the current running state will return false. Important test, actually, this one. Let's see. Let's register the attack state. Well, let's register both these states. So register, okay, register this. Register this. Idle. And then, no, registered attack. And then expect SM trigger attack to be true. Expect the trigger state idle to be false. Okay, and we have the update now. If has queue. How do we queue a state, actually? By queue state. The thing that I didn't test. This is interesting. So trigger test. Queue. Start with the basic queue state and empty state. So add new state. SMQ state. Well, I should. So queue works on the existing states. So I have to have registered states prior to doing this. So the queue works on this is interesting. The queue works on existing states. So we have SM trigger state idle, and then queue state attack. Now, how is the logic here? Can be overridden queue if current state So I need to simulate that the current state will exit. I know exactly how to do that. So let's put a new state like healing state. If tick equals 2, let's exit. So trigger state idle. Update, and now we queue this and we call update once again, and if the state is finished, then it will take the next state. And what should be the test? Expect SMQ SQ as q to be false. Expect sm get current state to be instance of attack state. Okay, so let's register state instance healing priority 2. So here we queue up healing. And we update once. Actually, we should have queue up healing. So we triggered. We triggered this, and then we queue up idle state. Now, the problem here is that if you queue a state that is higher in priority than the current ongoing state, it's not going to do anything. This is subject to change indeed. I don't think I really covered all the possibilities here, but there's one. There's one with the triggering unknown state. And that should trigger the default state. So adding a new unknown state. So 2 updates here and 1, 2. Guess we need 3. Why is the current state healing state? Let's find out. Okay, so the third update is the healing date. We are tick 2. Okay. So it current status is finished. Take this out of queue. Delete it from queue, trigger it. False. Oh. So we caught a problem. Trigger state. If not was successful, no, only if it's successful, return. If it's not successful, just go with the logic. So that's why I love writing unit tests, because you can catch anything, even when you have even when your coverage is 100%, it doesn't matter. So I have a small test to add here just to get rid of a message. Empty the queue. Queue state. Let's just throw a random first, second, third. Expect the same as Q to be true. We have 100%. Okay. I should commit this. Maybe rethink this. Don't like it. But what's good is that I can play with it. Description. Finite state machine. state priority supports doing custom states, state priority. And queued states. Okay. Code cover which is now 100%. Right. What? Oh, I need a README for this. That supports already written this. This is all package part of the library, but can be used independently. Usage. State manager SM. State. Registered states have to extend the class state, or you can implement your custom actions by extending enter enter exit and update. The methods enter exit and update. Okay, with this push, let's look at some responses here. And my eye has been caught by this question here. Where should complex state logic in an ECS reside? This is from 8 years ago, and it was modified 2 years ago. So I think this is still relevant in some way or another. I've been using ECS for a while. At the moment, I'm using my own, but it's pretty standard. Components are data only, entities pretty much just a map with some additional metadata, and systems that match combinations of components and contain the logic. You have combinations of components that result in a more general functionality. For example, position plus graphics give me some nice static background image. Position graphics physics give me an entity that can move around. These are like prefabs, but also these components are fed to a query. So yeah, a query that has entities with position and graphics, probably it's a background image, but something that has position, graphics and physics is an entity. So this question is about the various options for implementing more specific game logic. But say I want to implement a door. It has position, graphics and collidable hull, but it needs two states, open and closed. When it's open, it has texture A and its collidable hull is disabled. And when it's closed, it has texture B and its collidable hull is enabled. Let's say the state change should be triggered across some internal channel in the engine. What are the options for implementing this state change? Option 1 is to create a door component, with two variables, door state and state change channel. I'd also need a door system that handles the logic to manipulate the components when it receives open close message, correct? Option 2 would be to create a FCM. The FCM is probably also a component with a corresponding FCM logic. Not sure about that. If the logic is complex, like I just coded here, like in this finite state machine, you can't put everything in a component. Or I don't know. Let's see. Logic and state would need to reside somewhere, exactly, possibly by subclassing the FCM or having a generic property map in the FCM and static logic functions for the door defined elsewhere. Yeah, I pondered that, but I don't know yet. There's a more exotic alternatives to FCM, actions list and or behavior trees, but they are similar to option 2. I don't know how a behavior tree can help you when, for example, maybe you want your door to be opened for an amount of time or amount of frames. I don't know. What considerations are there for choosing a full component system over a more generic FCM type of solution? What if I had 100 different game objects with different behaviors? Would you really expect 100 component system pairs for each one, or would you try to create a more generalized solution? I've tried both pure approaches in the past, and not surprisingly I found a hybrid approach is best. I tend to create a lot of custom components for individual entities and use FCM when I need to change a lot of entities at once. So instead of attaching the, instead of attaching the FCM to the component, he's saying that you have an FCM like a system. Let's see. Almost always the FCM really only cares about one common aspect of the collection of entities. Okay, so here at states, I have to draw this diagram. So let's see, state. Component add. Okay. state manager. And the question is here. I don't even know what color should the state manager have. Question is here. Do you attach the state manager per entity? So then you end up having each entity with a state manager, or you have a state manager and all your entities are linked to it. That's our current situation where we at right now. Because then this resembles a system, but it's not necessarily a system, it's just a state manager. Let's see. In the door example, I would build a custom component that handles the door logic. But you see here in this sentence, you are already stepping out of entity component system. Imagine the size of it tiny and it will do exactly what you want. Now imagine some generic component that will work for your door as well as a toaster. This case is certainly more complicated than the first component and probably doesn't do what you want and is impossible to change. Second comment, I would rather treat the component system a means to invoke logic and nothing more. Instead, you design a generic component that manages a logical Boolean state of 0, 1. As the component's state transition to 1, you fire the activated script. As it transitions to 0, you fire the deactivated script. The benefit here is whatever logic you need is external to the ECS, as the component is merely a means to invoking logic regardless what it may be. So I would rather treat the component system a means to invoke logic and nothing more. I don't understand if the system or the component, because of the way. Instead, you design a generic component that manages logical Boolean, and as the component state transition to 1, you fire the activated script. Is external to ECS, as the component is merely means to invoking logic regardless of what it may be. In fact, the component could have a time factor associated exactly to the transition, so it takes X number of frames or nanoseconds to transition and allows for a tri-state like script executor rather than just 2. Now this component can work on door switches, vertical, horizontal, moving platform, flashing lights, etc. Basically anything that manages 2 or even 3 states. Okay, so you have a totally generic state component, but where does the door logic live and how it is associated with the entity? Would you have a generic FCM component to hold the script and an associating system? It's a good question. Assuming Lua is your scripting language, the component would harbor 2 Lua scripts, one to fire when the component is first placed in active state, and one when the component is placed in an inactive state. The scripts open door, close door contain your logic for the door. The component itself is the FCM interface that allows you to toggle between running 2 scripts to perform whatever activity you need. In other words, think of the scripts as your leaves in a behavior tree and the component as an inner node. So not a true answer per se, but as an insight. Apple's gameplay kit has an implementation that allows you to use a component to encapsulate logic and systems to manage the timing of component updates in relation with other systems. The entities themselves are able to update all of their components without the need for a system at all. Wow. The entities themselves are able to update all their components without the need for a system at all. My personal addition to this kit allows for the concept of systemic components that, if managed by a system, are ignored by entity updates. My editor is able to update components that need to update themselves during editing by declaring systems of that type and avoid all systems and all entity updates in general, since we are not running gameplay systems all the time. If you want to use a system for components that are specifically data structures, then the logic can be included in the system like any traditional ECS. Yeah, but where do you keep the state again? I think on the component itself. Having entity-driven component updates may not be the most data efficient method, but I think having the option and a precise method of handling components when a system is introduced makes it trivial to build or debug an entity when components run into conflicts. With a system-driven system, it is harder to manage simple entity-driven updates since each requires the system to run on instead of their own update methods. Correct, but is not harder in my opinion. They provide a generic entity component and component system classes. Component system. Component system. That all contain an update with seconds method. Creating a new system can be as simple as initializing one for a certain type of component subclass and adding the component with the call add component. My subclass manages each component's isystemic var and allows you to call update on specific entity or component system. Component system. Sometimes data processing requires efficient systems, but during prototyping, development flexibility is key. Well, Apple gameplay kit. The abstract superclass for defining state-specific logic as part of a state machine. GQ state abstract class defines the features of state classes to be used with a state machine. You build a state machine by defining a separate GQ state subclass for each state of. Okay, I'm doing the same thing. In each state class, you will use isValid next state method to define which other states are valid for a machine to transition into. Okay, this is the part that I don't have. I'm just relying on priority. State classes provide a place to put state-dependent game logic, such as actions that could happen when entering or exiting a specific code, or per frame. Ah. State classes provide a place to put state-dependent logic, such as actions that would happen when entering or exiting a specific state. Exactly like here. So you have enter, exit, update. Or per frame update code that is valid only when is a specific state. This is good stuff actually. Initialize the state machine that owns this state object. Okay. What were the dependencies here in the old engine? So in the old engine, the only external dependency was the entity that the state acted upon, because it acted on a component and an entity as well. Handling state transition, did enter, perform custom action, update, will exit, performs. I like this. I also like this that it has the previous state. Will exit to. Okay, now the idea is how do you use this? So an enemy character might use the state machine with chase, flee, dead, and respawn states. Each of these drives the enemy behavior. The state transition determined by player actions and elapsed time. Now the question would be, how is this used in an architecture? State machine for game UI. Building a game with state machine. Define actions. Okay, at any one time a state machine has exactly one state. When you perform a per frame update logic for your game objects, for example, from within the update method of a sprite kit scene, or render update the time method of scene kit and the delegate. Call this. Okay, when your update logic change state. This game uses a separate instance of the state machine summarized here. Each state in the state machine is a subclass, yes. Specific state, all 4 states class make use general user information. Okay. Most of these state classes need no additional public properties. All information they need about the game comes from the reference of the main Apple game. Okay, so they have a reference to the main object. This reference is weak because the state objects are owned by state machines, which in turn are owned by entities. Exactly. Each of them owned by game object. Each state class then defines state behavior. Create and drive a state machine. The maze game, an Apple intelligence component object manages the state machine for each character. So they have an Apple intelligence component. To learn more about component-based architecture, anti-component setting up a state machine is simply a matter of configuring. Okay, so I need to read this, but let's finish. Apple intelligent component. Init with the game. Okay. Creates an instance of Apple intelligent component class for each enemy character. So they have a different type of component, which is this intelligence component. In turn, the state machine calls update. So I guess these are not serialized, possibly, or they are differently. Set power up. Okay. Okay. And then I need to read as with any piece of software, designing a complex game requires planning a good architecture. Some designing decisions that come naturally when building a simple game demo can become hindrances as your game becomes larger and richer. Gameplay Kit offers an architecture that helps you plan for better reusability from the start, separating the concerns that have to do with different aspects of your game. In this architecture, an entity is a general type of objects for objects relevant to your game. Entities can represent objects that are crucial to the gameplay, such as player or enemy characters, or objects that merely exist in the game world without interacting with the player, such as animated decorations in a level. Entities can even be conceptual or UI elements of your game, of course, such as a system that decides when and where to add a new enemy character to a level. Or a system for managing equipment worn by the user player character. An entity gets its functionality by being a container for components. A component is an object that handles a specific limited aspect of any entity's appearance or behavior. Because a component's scope of functionality is limited and not tied to a specific entity, you can reuse the same component across entities. Example boxes. Each box entity in the boxes game is defined by a set of components as shown in the figure. Individual components are unaware of each other and of the entity they belong to, so they can easily, yeah, I have this already. Let's see here, the entity component. So they are talking about entity component design pattern and not entity component system, which is very important. Is an architecture that favors composition over inheritance. To illustrate the difference between inheritance-based and composition-based architectures, consider how you might design an example tower defense style game with the following features. The player has a base location on one side of the game field. Enemy character periodically appears in wave on the other side of the game field, proceeding towards the base to attack it. If too many enemies reach the base, the game is over. To prevent enemy from attacking the base, the player places towers. Okay, this design is easy to model using inheritance-based design. A base class could model the base which okay, an enemy class could provide a display representation and logic to handle movement. A tower class could provide the display representation logic to handle targeting. All of these classes need to handle a visual representation so that functionality can be implemented in a common game object superclass, resulting in a class hierarchy as such. Inheritance-based architecture hinders game design evolution as you refine your game, you add new capabilities. So game objects base health should move, shooting enemy. So for example, you might add enemies that fire back at the towers. However, this represents a problem. The new shooting enemy class can't reuse the targeting and firing code from the tower because class it doesn't inherit from that class. To attempt to solve this problem, you might move the code into game object class so that it can use it on both tower. Yeah, okay. However, if your game design continues evolving along these lines, eventually one root class holds nearly all the logic. Yeah. So composition based architecture make evolving game easy. Instead of organizing the game object model in terms of what each game object is, the entity component pattern encourages you to think about what each game object does. In this example, you can make components for each bit of functionality that might be expected of a base, an enemy, and a tower. One component might handle visual representation, another might handle targeting and firing, another might handle movement. Still, another might track how much damage has been sustained and update an UI element accordingly, and so on. Create a new subclass of GQ component for each unique area of functionality. See how this looks. GQ component. Update. Okay, so components have update. Components have logic. Each time a game update handlers executes, for example, update method or the renderer. What about GQ entity? Component adds components, and this has also update. Perform periodic updates on each entity's components. This is interesting pattern. Per entity updates in a game with a few entities can iterate through a list of active entities in a game. Call update with delta time. Per component updates in a more complex game, it can be useful to ensure that all components used by entities update on a strictly defined order without needing to keep track of which entities have which components. You can create a GQ component system objects, each which manages components of a specific class. Okay. So now we're able intelligence component. This class is used only by enemy character entities and provide the logic that allows them to move independently and react to player actions. To keep track of what an enemy should be doing at any given time, the intelligence component uses a state machine, C state machine. Where is this? It gives me stuff about stock. Okay. Rule systems. Because the intelligence component is generalized, it could be reused for other kind of entities. For example, a future variation of a game could include computer control ally. What are these? Some kinds of games include complex sets of rules. For example, a role-playing game with turn-based combat might include rules governing what happens when opposing character moves into the same space. Who has the upper hand? Okay. Fuzzy logic. Is an approach to variable processing that allows for multiple possible truth values to be processed to the same variable. Fuzzy logic attempts to solve problems with an open, imprecise spectrum. Boolean is 1, 0, and fuzzy is based on observation. Okay. A rule system that treat decisions as continuous variables instead of discrete states, leading to complex behavior for even simple combination of rules. I mean, that makes sense with the states. JK rule. So you can have these kind of conditions which are helping in decisions. Okay. Implementing state-driven agents in an entity component system. A state-driven agent is an agent that performs an action based on its current state. The logic can be implemented through the use of a DFCM that changes state depending on the agent perception and stimuli, and performs action on entering, being in, and exiting a state. I'm trying to implement this type of design in ECS. My first thought was to implement an FCM component containing a current state and a rulebook, a system that updates the FCM component current state depending on its rulebook, and a system that implements the actions of an entity and modify its components accordingly depending on the state of the FCM component. I'm not sure this is correct ECS implementation, and that I can cleanly represent enter, exit state, perform an action behavior. So how should SDA be implemented in a ECS architecture? The approach I have taken in the past was to separate the behavior and the AI aspects into two systems, much as you described. One, on the behavior side, you have a series of predefined aspects that can be chained together in a behavior tree like patrol, attack, threat detection. Again, I think this misses the mark. The benefit to separating the behavior is in this way is you can create a series of serious behavior tree patterns. On the opposite side, when you create an AI controller, I must give the AI controller behavior tree. Assuming that there are only going to be a small number of FCM classes, one for move and one for AI, then I would make each state a component. In this component will be encoded in states of two different FCMs, although you will have to have a separate place for each entity to actually keep track of which state it's in, such as an additional AI component. Why are all the answers so complicated? Like the questions were straightforward. Developing a top-down game using JavaScript and Canvas with ECS. Check blinkability, execute. So method number one, combining the ability function and its metadata into one object. I thought about this as well, but there's no state here. There's only the position change, so the state is kept here. But where do you keep this cooldown stuff? Separating ability metadata from its function. I know in general in the ECS architecture it is wise to separate state from actions, but I'm not sure if this would also apply to things like abilities. It seems like it might be wise to maintain that separation, but the code seems like it might be cleaner. I'm not really concerned with the performance differences between two approaches, but rather which is better from a design standpoint. I'd argue you should keep the implementation alongside the definition in this case. It gives you a lot of flexibility, but you don't want to be serializing methods, so your player NPCs should have reference to the above via ID, queue, and serialize, assuming hotkey If you make sure you execute method definitions as broad as possible. Yeah. Having the player as an entity would mean having a system just for one entity that holds player component. Yes. Tech tree and updates to tech tree. Tech tree cannot be an entity since you want buildings to have their own tech tree, so you must be a component them. I'm not satisfied with this. Add an event bus to systems. Create components for each immediate state. Systems. Implement an onEvent method that takes an event and an entity as input, signaling that the entity has received the event. Every system also subscribes to event and entities with a specific set of components. The only point of interaction available to the systems are entity manager singleton used to send events to entities and retrieve components from specific entity. When the entity manager receives an event coupled with the entity it is sent to, it places the event on the back of a queue. While there are events in the queue, the foremost event is retrieved and sent to every system. Is talking about queuing, which we have in the state machine, but I still don't know. Okay, so no conclusive answers. ECS finite state machine on entity or system. Okay, I read this one. because how we query which entities are moving, how many unique tags are we going to have to check for. Movement component is better. If they aren't moving, they don't get the component. If they have the component, how fast they are moving stored in it. You may want to implement the state machine in a single system, which probably is the most common way to do. You still might have to query on specific states in other systems, however. Like, do this logic only for entities that are attacking, or show me all entities that are idle. So then the question is, when the additional algorithmic complexity of having the ECS do it is filtering for M components less than OMN and number of entities. Yes. ECS systems use storage method that allows efficient iteration. Don't care about tags. The states are entities, but they're not used when setting up things that use those states. Why wouldn't it make sense to formulate it like this? So archetypes-based solutions store entities with the same sets of components together, for example, are stored in a different archetype than position, velocity, mass. This lets you store components and densely packed arrays. entity does not contain any state. It's not of a particular type. In a traditional pig game, you might expect a tank to have the class tank. Correct. Okay, so state is not mentioning here, it's only once. Okay, I think this topic I need to read in detail tomorrow, but I think the most sensible decision I can take here is to just dive into coding and see if what exactly I need to do. Because it feels like I need a system specifically for this. It's just that the FCM, I don't know where to keep it. So maybe the FCM will be part of a system and we'll iterate through each entity's FCM. or yeah, I don't know. We'll see. So tomorrow I'm going to resume my work and make the attack state work. Because right now I messed it up with some changes. So I need the last thing I was doing is playing with some specific components, but I think this should be states. So have have registered states. So on entity I would register some states to the finite state machine, and those states basically operate the logic on the components. So they store their state on the components rather than the state itself. So state is only a container for execution for logic, the state class. Okay, I think I am starting to get a picture here. Okay, so talk to you